Hi, and thanks for watching this video. I'm Andy Sterland. I'm a program manager on the Visual Studio Tools team, focusing on HTML and JavaScript, and I work on the developer tools in the Edge browser. Today, we're going to be taking a look at instrumenting your code for profiling using the Edge developer tools. I've got a set of a few demos here to really show you how you can use the tools, and as well as some APIs in the browser platform, the web platform, that allow you to capture information about your application as it runs in the wild, so that you can be a better and more effective profiler. The first demo we've got is really using the console, specifically the console.time, to do some quick and dirty measuring. So taking the start time of some function, taking it to another point in your code, and timing the difference. Then we'll look at some APIs that are available, performance.mark, performance.measure, for how you can instrument your application to define scenarios that you can collect in the wild, as well as how you can use that information locally to profile traces. And lastly, we'll finish up looking at the memory tool and how you can use the memory tool in conjunction with some APIs from the console to get accurate memory collection at the right time in your application. So let's take a look at the first demo. Okay, so in this first demo, I'm going to show you an example using console.time. I've got a really simple application here, and the purpose of this demo is really just to give you a flavor for how to use the feature, so that you can go away and use the feature in your day job and the pages you debug and stuff like that. So the example obviously is a bit contrived. It's not terribly complicated, and I don't think many people are going to debug this. So we're just going to load up the tools to get started. Now, one handy hint about the tools is you can use the Control+ keys to zoom in just like you would your web browser. So if in like this example you want to see some bigger text, Control+ to zoom in, Control- to zoom out, and then Control-0 to get you back to 100. So just like zooming in the browser. So hopefully this makes the text a bit clearer. So the value of console.time is really that it's used to replace something you've probably done already. Like I'm sure in your applications at some point you've done something like this. You've got start date, which of course you've taken a new date, and then you have some code that executes. Then later on, you take the new date and you take the old date. And that gives you the time in milliseconds that happened between here and here. So using the date object, it's a good place to start. The date object is milliseconds since the 1970 January the 1st, so the epoch. And of course, subtracting gives you the time in milliseconds between the two. The downside of this approach is that you've got some code, obviously, you've got to have some state. You've got to store these variables somewhere, you've got to pass them around, things like that, which is a bit inconvenient. And of course, it's also only accurate to 1 millisecond, which might sound like a lot to me and you, and certainly in human times, that's an awful lot. But for a computer, at 60 hertz and 60 frames per second is what you want to keep your app at, you only have 16 or so milliseconds to deal with for every frame. So instead, to make this even easier, there's an API that all the modern browsers implement called console.time. And in console.time, you pass in a label, and then you call timeEnd, and you pass in another label, and it measures the time between them. So looking at my application, I've got a busy work function that just basically generates a random string. So it's not even that super useful. And what I've done is I've set the console.time before the start of the function, before the start of the code rather, and then at the end. Now it's important to note that even though in this example, it's all in one function in a click handler, these two events, these 2 points of code could be separated across any distance. They could be in different event handlers, they could be in timers or whatever. They just can't be across refresh. You must use these functions, or these labels inside a page navigation. Once you navigate your page, all that data is lost, so you can't use it. Okay, so the function is really simple. I'm just going to press go console time, which executes this, and then look over in my console. And unsurprisingly, you can see the name of the we gave, which was just example, pretty original, I think, along with a time in milliseconds. You'll note that it's sub-milliseconds. In fact, this function's accurate to 1,000th of a millisecond, so it's a high-precision timer. And again, you can keep measuring it. Interesting enough, in this particular example, it gets faster after the first iteration, as the runtime engine Chakra has had time to optimize and compile that code. But there's one other important note when you do profile your code that's worth keeping in mind. In this scenario, I've still got the debugger attached. Really, I want to detach the debugger, since debugging has an overhead for applications. The debugger obviously has to listen to events, subscribe to notifications, things like that, and also de-optimizes things like exception handling and whatnot inside your application. So I'm going to disconnect that debugger, just using this toggle here, the debugger toggle. And now when I use the function, it might have slightly different performance characteristics. You can see it's dropped slightly. In this case, that was pretty insignificant, but in general, turn off the debugger when you disconnect the debugger when you want to profile. And that's good advice. The tools, if you use the performance tool or memory tool, they'll do that for you. The other thing that's nice about console.time and time_end is because it's just taking a string as a label, as the name of the function, you can of course provide dynamically generated functions, names. So in this case, I've got a nested console. And since the console.time and time_end is just paired on the label, you can of course have as many of them open as you want, so long as the labels are different. And here, as you can see, it's logged 100 console messages. Not the most useful thing, but I'm sure you can appreciate that in your scenarios with a more complicated application, that could be much more useful. So there's a simple example of using an API, console.time and console.time_end to replace something you probably already do. So in this demo, we're going to be looking at two functions, performance.mark and performance.measure, that have existed since, I think IE10 in the Windows platform and for a while in other platforms. For those of you who are not familiar, the performance is a standard object implemented in most of the browsers. And if you look at it, just in the console for the sake of argument, you'll find there's all sorts of interesting data. So that's the first interesting thing here is window.performance, just performance of the window object, has, I guess, two real sets of data. One is around timings for things that relate to the web platform. So in this example, you can see I've expanded the object in the console. I've got a bunch of numbers, times, for various important dates or important marks in your application's lifecycle, such as when the connection started, domain lookup, DOM content loaded, DOM interactive. So obviously, this is important milestones. So when you're building your application, you might be very curious to know when DOM content loaded is finished, because that's the point in your application that perhaps the user is ready to interact with it. Or for an app that's meant for consumption, you might want to use the first paint, which is essentially time to glass. The time that it comes to render that first real big frame from the engine. And so this is interesting data that you can collect and you can upload to your backend. So if you had like an analytics engine, perhaps they already used this, but if not, you can certainly roll your own and serialize this to a JSON object and XHR it up. On top of that, that's really good for static applications, for applications that are just, like displaying content. If you have a long run application, like, a single page application, or something that has lots of rich interactive JavaScript, like you display a complicated form or a grid, that information isn't that useful because it's only relevant at the start. And that's where performance.mark and performance.measure come in. So performance.mark is an API where you pass in a label, a name, essentially, and it allows you to annotate code. So I have an example here where you can see that what I've got is I've got a mark at the start before I invoke a function. So this is an example of a scenario. So in this case, it's a single function that's generating a string. But for your scenario, it could be someone writing an email, calculating something, displaying a form, whatever it is. And then you put it something at the start, and then you put performance.mark at the end. And that provides 2 points in time that are incredibly important for you, like it provides the start and end of a scenario. And if you wanted to, you can then get access to these from the console or from the page, because normally you'd have your code access this and you wouldn't do it from the console, that's a bit balmy. And window.performance, and you can see, of course, that if I run this code and then evaluate it again so we get the up-to-date data, and if I go to the timing, you'll see user functions. Let me make sure it appears. Let me just evaluate that. Oh, I forgot. Sorry. Window.performance, you got to call a function called getMarks. So let's just call that. My bad. It's not off the performance object. I know what I was thinking. GetMarks. There you go. And of course, this returns an object table with the name of your marks and an array for the value of each one. Well, so you could go away and use these to annotate or provide data to your backend. But that's not the most useful thing. Probably a more useful scenario is you measure the time between two things. Because most of the time, you're probably looking to say that this particular action or this scenario takes X seconds, milliseconds, etc. So to do that, that's where this API performance.measure comes in. And you pass in a name for the measure, the name of your scenario essentially. You pass in a mark that represents when the scenario should start. And then you pass in a mark for when you represent the scenario should finish. And then lastly, you call getMeasures on your page to see that. So for here, for example, if I go back to the console, do performance.getMeasures, you can see that I've already pressed the button twice. So for each of the labels, I've got this thing here called the iteration-based calculation, and it's got two values. And this is the value in milliseconds and sub-milliseconds of that particular scenario. So you can do a scenario thousands or however many times, it doesn't matter. You just annotate your code once and this data will be collected. And then you can just serialize this to JSON. Pretty simple. Like you'd obviously do this from your code, not the console. And so if we do JSON.stringify, and then if we do performance.getMeasures, we want this one here. Thank you, in autocomplete. Save my life. You can see you've got a string that you can of course upload to something and track. And that would give you a KPI. And there's some analytic products out there that already include this data, so it's interesting for that reason, if nothing else. But the real value of the data isn't just in building up a KPI, because once you have those measures that measure your real user metrics, essentially, the performance that customers see in the wild, be it in remote locations or on different devices like phones, for example, and whatnot. And again, performance.marketMeasure implements in pretty much all the browsers, though I do believe they're not on Safari or OS yet, but they certainly are for Android and Windows. So once you've got that information, once you've got the KPI, once you've got the data, often you'll be asking yourself, well, okay, so it's long. Now I need to profile it and really get a sense of what's going on. And in this scenario, performance.mark and .measure are still very useful things. So just like you normally would when you profile, you start profiling in the performance tool. And I'm going to run the scenario by pressing go. And I'm going to stop profiling. And that, of course, will collect all the data. So one of the first things you'll probably notice about a performance tool is they can be a bit overwhelming. They show you a lot of data. That data is valuable because it obviously helps you diagnose your performance problem and hopefully helps you resolve it. The downside is that it can be awfully confusing to figure out what's relevant to the scenario you're profiling. So like, for example, you can see along the top here, we have a timeline that's 1 second to 7 seconds, but I don't know, and I don't think anyone could really know if the scenario started at 1.2 seconds, or did it start at 3 seconds and end at 5, maybe 5.2? There's no way no human person could ever understand that. And that's another place where user marks and user measures come in to be super handy. You can see along this timeline, because the thing with the timeline you're doing by selecting like 2 seconds and 3 seconds is you're trying to select a range for which to look at the data from just that data range. So you try to reduce down the amount of stuff that you can see so it makes it, that you're only profiling the relevant things. And by using user marks, you can see along this timeline along the top that the marks are here. So you can see those are the 2 marks in the center, the end of one, the beginning of the other, and the end of the other. So of course I can manually adjust them to match that as a little snapping action. That's also a bit of a pain though. And if you look down to the profiling tool, what you'd notice is there's these user measures. And so each of the measures in your application will also be shown here along with its name. And so you can very clearly tell where the time is, but more importantly, you can do something like right click and then filter to event. And what that does is it scopes the timeline just to this particular scenario. So you can ignore everything else. All the call stacks, all the events will just be limited to things that are relevant to your particular scenario that you've captured with performance.mark and performance.measure. So for example, here you can see the click event, which is obviously relevant. It also has the nice highlighting. And then you can see I was generating a lot of strings, so there's quite a bit of garbage collection. But the more important thing is the call stacks. So here, this is where you see the sampled call stacks from your code executing. And that is the thing that you'd probably want to profile and look at in this particular scenario, because this scenario is all CPU script bound. For me, it's just an example, but hopefully you can see how you can use these features and you can translate them back into your application, your website, your web page, whatever you're building, even in hosted web apps or whatever it is. So hopefully by using performance.mark and performance.measure, you can collect KPIs for your site, but you can also use them to better profile your application. Okay, so in this demo, we'll be looking at using a function on the console called console take heap snapshot. This function is there to help you, as a developer, tell the memory tool when to take a snapshot. It's simply called by your code. Now, one thing, of course, is you're calling this from your code. You should make sure that you check to see if it exists.
From shipping
For the sake of the demo, it won't have much of a really simple example that we're going to look at,
making sure you don't get
and I haven't checked to see if the console
anyway.
take heap
So in this
snapshot
particular
is
example,
defined.
I'm going to show you how you can use
Obviously,
this
you
feature,
should.
the memory
Even
tool,
better if you
to
can
easily
compile out
investigate
console
potential memory
APIs from your application.
So
so
here,
ship.
the setup of this demo,
Because not all browsers support the same
related
console
scenario.
APIs.
We've got a dot
certainly not when it
element,
comes to
which is
phones
just
and
this
things like
text
that. So
div here.
if you can find
And
solutions
what
we
we need to do, or what I'm going to do, is I'm going
anything
to
that calls
parent it to
console log
window,
or anything,
so making it essentially reachable
from shipping
global,
applications.
Window
It won't have much of a perfect impact. It's really about
object,
code cleanliness
and then I'm
making
going to
sure you
remove
don't
from the
get
DOM.
unfamiliar exceptions.
So after this code executes,
Anyway,
what will
so in this
happen
particular
is that
example, I'm going to show you how you can use
an
this
object,
feature,
a DOM
the memory
element
tool,
that's no
to
longer
easily
DOM
investigate
tree, so it can never
potential
render
memory
or
issue.
participate in event handling
So
and
here,
stuff like that.
the setup of this demo
But it
is
reachable
quite
from
contrived, but
JavaScript,
you
so it's
probably relate
not
to the
gonna be
scenario.
freed.
we've got a DOM element, which is just this text
but
div
it is
here.
never going to go away.
And what we're going to do, or what I'm going to do, is I'm going to parent it to window,
heap
so
snapshot
making
at
that
that point in
essentially
time.
reachable from global.
So
window being the
you've used this
global
console
object.
snapshot,
And then
so
I'm
imagine
going to
this
do this in the
scenario.
DOM.
I've discovered that
So after this code
few
executes,
lines of code,
what will happen is that there will be an object, a DOM element that's no longer in the DOM
Many
tree,
times,
so
of
it can
course,
never
when you're
render
looking at
or participate in event handling, stuff like that. But it is
the
reachable
memory
from
tool,
JavaScript.
you'll be looking for
not
a
going to be
leak.
freed.
Like when a value
It's
is
not necessarily
in
a
a
leak,
scenario,
but it is
you show
never
a
going to
grid
go
of
away.
data or whatever you're doing. And at the end of the scenario, the memory is higher
I'm
than
just
the
taking a
beginning
heap
of the scenario.
snapshot at that point in time.
So normally when you're using a tool, a memory snapshot
you use
tool,
this
you'll take
constant
a
heap snapshot.
as
So
a
imagine
baseline.
in this
You'll take
scenario,
a
I've
snapshot
discovered
at the
that
start of the
after these
scenario,
few lines of
a
code,
snapshot at the end of the
there's an
scenario.
increase in memory.
Which
So
works
this is a good
great.
quantitative
You know, here you
snapshot.
are on the memory tool.
Many
Let's
times,
start
of
the memory
course, when
tool.
you're looking at
You
using
start the memory tool, everything's chugging along. You press
the
this
memory
button,
tool,
press
you'll
this
be looking for a
button,
leak.
take
Like
snapshots.
when a value is
You run
the
a
downside
scenario,
is
that can be difficult to coordinate
you show
what's
a
going on
grid
in
of data or
application.
whatever you're doing.
You know,
And at the end of the
ability for you
scenario,
to move the
the memory's
mouse
higher
and
than
the
the
focus
beginning
to
of
the
the scenario.
tools in coordination
So
with
normally when you're using a
your
tool, a memory
application,
snapshot
which is
tool,
the
you'll
ability
take a
here
snapshot
to line up
as a
basically
baseline,
your memory
take a snapshot
at
at
the
the
start of the
right
scenario,
time,
and a snapshot at
can
the
be a
end
bit
of the
tricky.
scenario. So that's where console
Which works great. You know, here you are on the memory
comes
tool.
in and it
Let's
takes
start
a
the memory
snapshot
tool.
at a certain
You
point
start
in
the memory
the
tool.
code.
Everything's
So
chugging
at
along. You
that
press this
point,
button. Press
you
this
know, you can get your memory
button.
snapshot.
Take snapshots.
The interesting
downside
thing
is
to be
that
very
can be
technical
difficult to
here
coordinate what's
is
going on in
that
your
the snapshot
application.
actually
You know,
happens
the
just
ability
after
for you
you've
to
gone
move
back
the
to
mouse
global.
and move the focus to the
So,
tools
in general,
in coordination with your application.
memory
It's
snapshots,
the
like, for
ability
example,
here
if it was to
to
happen
line
just
up,
here,
making sure your memory
local
snapshot
data would
is
be
done at the
available,
right
it would
time.
be available,
And that
but
can be a bit
locals, of
tricky.
course, will be
So that's where
dismissed
console
as soon as
take
the stack
snapshot
clears,
is.
which can happen
It comes in and it
instantaneously
takes a
in this
snapshot
case.
at a certain point
And
in
so
the
really,
code.
as soon as you say this
at
command,
that
what
point,
happens as soon as the event
you
loop
get your memory
finishes,
snapshot.
so as soon as you go back to
The interesting
platform
thing,
and
and to be very
JavaScript
technical
executed,
here, is that the snapshot actually happens
so that's still really
just after
powerful
you've
because
gone
of
back
course
to
everything
global.
in the web is
So
event-driven.
in general,
And as a general rule, having data
memory
that's
snapshots,
just,
like for example, if it was to happen
during
just
like
here,
like
local data would be
stuff,
available,
so
would
stuff
be
that's in
available,
closure or whatever,
but locals,
just
of course,
because
will
the
be
execution
dismissed as soon as the stack
context, not
clears,
that
which
relevant.
can happen in your
So anyway, the memory tool, we've got
case.
chugging along here,
And so really,
we're
as soon
detach our
as you say
scenario.
this command, what happens as soon as the event loop finishes,
So as soon as you go back to the platform
we're
and
gonna
your
quickly
JavaScript
refresh
starts
the page
executing,
because the thing didn't work.
snapshot happens. So that's still
And
really
we try
powerful
again,
because of course
and it
everything
works.
in the web is
Yay.
event driven. And
Okay.
as a general rule,
So,
having
as you
data
can see
that's
here,
just
you've got a snapshot.
you know,
The nice thing
during like
locally scoped
thing
stuff.
here is also we
So
got
stuff
stuff
that's
that's
in a closure or whatever,
information warning,
just
telling
because
us
of
the
the
execution context.
snapshot.
So we're going to click this link here.
So anyway, the
And
memory
you can see
tool
what
we've
it's
got
done
chugging along here.
is it's highlighted
We're going to
something
detach our scenario
with this particular identifier. So of course,
You're gonna run it.
if you zoomed in a
We're
bit,
going to quickly refresh the
you can
page
see
because
that
the thing
they're
didn't
saying
work.
that the orphan, and you hover over and it's saying
And
this
we're
is
gonna try it
attached
again,
on node.
and it works.
Now it's an
Yay.
information because we don't actually
Okay.
know if this is a leak.
So
there's many
as
good
you can see
reasons
here,
to use
we've got a
detached on
snapshot.
nodes.
The nice
Libraries
thing
often
from
use it, for
pressing that
example, to
button.
construct
The nice thing
objects
here
and
is also we've got
templates
this
and
little
whatnot before
information
attaching them
warning,
to
which is
the
telling us
DOM,
something to
the
look
markup
at in a
tree.
snapshot.
So there's
we
valid
click this
reasons
link
to use
here.
this. It's up to
And
you
you
as
as
a
a
developer
developer
to
done
decide if it's
is
valid
it's
for your
highlighted
application.
something
But
wrong
once you've
with
decided
this
it's
particular
invalid,
identifier.
look
So
at the
of course,
object references
if
below,
you,
and you can
zoom
see
in
the
a bit,
paths back to global.
you can see that
And of
they're
course,
saying that the
JavaScript
orphan,
being a garbage
and you
collected
hover over and
world,
it's saying this is a detached DOM node.
what you have to do
now,
is
it's
to
an
remove
information
objects,
because we don't
snip,
actually know if this is a leak.
all
There's
the
many good
references back
reasons
to
to use
global
detached
root,
DOM
or
nodes.
back to root
Libraries
to
often
global
use them, for
root in this
example, to
case.
construct objects
And then, of course, it'll
templates
be
and
freed
whatnot
up when the garbage
before
collection
attaching them to
next
the DOM, the markup
So in
tree.
this case, it's
so there's
directly
valid
off
reasons to
global
use this.
window.
It's up to
So
you as a
I just
developer to
had to
decide if
remove
it's
window.
valid for your
By going
application.
in, delete
But
whatever.
once you've decided it's
You can see for the
invalid,
other objects, like the
look at the
document,
object references
these
below,
divs,
and you can see
their
the
paths
paths back to
is of
global.
course different,
And they
of
go
course,
up JavaScript
by
being a garbage collected
HTML
world
to the document. What you have to
So
do
attach
to
them
remove
all.
objects is snip.
You can also see that nice little
All the references back to a global.
So there was an
root, or
example
back to a
of
root
using
global
console
as
take
the
keep
root in this
snapshot
case.
at the right point
And
in
then,
your
of course, it'll be
code
freed up
so
when the
that you
garbage
can
collection
collect
next runs.
memory trace.
So in this case,
and
it's
you must
directly
have
off
the memory
global,
tool
which is
running for this to
window.
work. If the memory
So
tool
I
isn't
just
running,
had to remove from window.
then nothing will happen.
Nulling it,
Which is
delete
great
whatever.
because, of course, if you
You can see
forget
for the other
to remove
objects,
this
like
from
the
shipping
document,
code,
you don't want to
these
run
divs,
snapshots on every
their
customer
path
because
is of course
snapshots
different,
take a
and they
while to
go
up
depending on how many
via
thousands of
body,
objects you
via
have.
HTML to the document.
So it only works when the
So
memory
they're
tool's
attached
open.
to the DOM.
But what it'll do is it'll
You
take a
also see that
snapshot
nice
at the right
little
point in
integration
time.
for your application.
So there was an
You can
example
then
of using
use
console.keep
diff,
snapshot at the
otherwise
right point in your
investigating
code so that you can collect a memory trace, and you must have the memory tool running for this to work. If the memory tool isn't running,
All right.
then nothing
How
will
was that?
happen, which is great because, of course, if you forget to remove this from shipping code, you don't want to run snapshots on every customer because snapshots can take a while to run depending on how many thousands of objects you have. So it only works when the memory tool's open.
Bollocks.
But what it'll do is it'll take a snapshot at the right point in time for your application,
Okay.
which you can then
Yeah,
use to
I wasn't
diff
too sure of the client.
or
I
otherwise
was before we
investigate. Okay, so you've seen some great demos of how you can use the tools to profile your application. You've seen how you can use an API called console.time and timeend to profile and annotate 2 points in your code, so you can see time in the console pretty quick with a sub-millisecond timer. You've seen how you can use performance.mark and performance.measure to time scenarios in your application that you can then collect and potentially upload to your backend to generate KPIs and things like that, and how you can also use them locally to filter down results so you can very accurately delineate scenarios. And lastly, you've seen how you can annotate your code with console.takeKeepSnapshot, so you can take snapshots at the right point in your time to get the best memory dumps. So where next? Well, this concludes this video, and I will say that do please follow us on Twitter at EdgeDevTools. We have tips that go out on that channel twice a week, and you can get nifty little GIFs of things that are useful in the tools, like little shortcuts and things like that. And if you have any questions, do feel free to tweet out the team at EdgeDevTools. We're always happy to take questions and answer you and help you if you have any problems with Edge or the developer tools. And of course, feel free to go to User Voice. You can check out the link on the page, bit.ly at F12 User Voice, and then you can vote on features. So if the tools are missing a feature for you, search for it on User Voice and vote for it. Your votes matter. We take it into consideration when we're evaluating what features to build in future versions of our product, so please go there. And lastly, if you want more documentation or you want some guides and links to other videos, please go to edgedev.tools and you'll be redirected to our MSDN Doc Center. And of course, you can always find me, Andy Stilland, at Andy Stilland on Twitter. And please feel free to reach out to me anytime. Otherwise, I hope you have a great time using the tools, and I hope you found this video informative.